Hello everyone, I'm Chen. I will present im2im, automatically converting in-memory image representations using a knowledge graph approach. Okay, in many domains, data across libraries may represent the same abstract concept, but it's stored in diverse in-memory representations. So when combining functions from different sources in a single program, this difference forces users to deal with the conversion details. Managing these low-level technical details distracted them from high-level tasks. So our research addressed this challenge, focusing on image processing as a concrete example domain. So for example, imagine we want to use two functions together. The function on the left side produces the output here, and the function on the right side expects an input. So at an abstract level, both of them represent the same thing, an image. But in practice, you see, their in-memory representation differs. One may produce a PyTorch tensor in a float format, which value in the range 0 to 1 using RGB channels in a channel-first batch style layout on the GPU. So in contrast, OpenCV functions typically expect NumPy array in on-site integer 8 format with values in a different range, use BGR channels in a channel last layout on the CPU. So bridge this mismatch requires manually to handle conversion steps to keep capability, including device transfer and channel reordering, data types, and so on. So this low-level implementation, for example, here in the dashed box, distract the user from the high-level image processing operations. So a common approach is through using an intermediate representation approach. This method standardized data exchange by converting all formats to and from a fixed intermediate format. However, this typical approach has two limitations. First, runtime overhead. Every operation involves repeated conversions, such as going from IR to operation and then back. Second, it introduces development efforts. For each operation, developers must write and maintain conversion code to and from the intermediate representation. So we introduced im2im. It's automatic to convert in-memory image representations using a knowledge graph approach. So at the core of our method is a graph. So we introduced this novel metadata structure with the key features that uniformly describe in-memory image data across different libraries. Each metadata will form a unique node in the graph. And the edges between nodes represent valid conversions and are annotated with code templates that perform the actual conversions code across several libraries. So the graph was constructed to capture this metadata instance and their associated conversion codes across several libraries and frameworks. So to design the cost of a conversion edge, we benchmarked the execution time of each conversion across image size on multiple image resolutions. The results showed the execution time was negligible at all resolutions. So we do not include the execution cost as a factor in the edge cost within our graph model. However, some conversions like adjusting bench size or reordering channels preserve precision. Others, like converting from float 32 to integer 8 or from RGB to grayscale, introduce the information loss. So to capture this difference, we define an information loss flag. It's set to 1 if information loss occurs and 0 otherwise. Some conversions may modify one or more attributes at a time. So we computed constraint score, which counts the difference of immutable attributes by the conversion edge, plus a penalty if this conversion process crosses the CPU and the GPU boundaries. So the total cost of edge is just a tuple with these two elements. This cost is evaluated lexicographically, which means we prioritize preserving information and only then try to minimize conversion effort. Okay, so im2im just follows 3 steps: just search, synthesis, execution to perform the source image to the target image needed for this operation at runtime. So for graph search, so first im2im just retrieve the source metadata from the given image. Then, because many in Python or other language, many functions can accept multiple image formats. So system will identify the closed matching metadata for the target operation based on the preset. Okay, with both the source and the target metadata identified, we just use A* search to find the lowest cost conversion path between the source and the target metadata nodes. Okay, along this lowest cost path, the conversion code from each edge were collected and then assembled to executable Python snippet. This Python snippet can be just executed to convert source image to the target format. So that's all for our method. Pretty simple. Just A* search and then code synthesis, code string synthesis, and execution. Okay, so the first question is, can im2im guarantee a least cost path between image formats? Okay, let's first look at our heuristic functions. We use a very simple and safe heuristic. It just calls how many metadata attributes differ between the current node and the goal node. This captures how much transformation effort is still needed. So a heuristic function is defined as admissible if it never overestimates the true cost to reach the goal from the node n. So our heuristic function satisfies this property. So A* search, when guided by admissible heuristic, it's guaranteed to find the optimal path from the start node to the goal node. So okay, next question is, can it used in practice? So we compared the two approach, im2im and a baseline, which corresponding to a manually writing conversion code. It's only executes pre-compiled conversion snips. So there was no existing benchmark for this task. So we just performed the brute force evaluation. For each every possible conversion between all spotted image types, we generated random images of various sizes, then measure the execution time when using both methods. We found the relative overhead of im2im decreased with increasing resolution due to a monetized of graph search and synthesis. This is because the cost of the graph search and the synthesis This is because the cost of graph search and the code synthesis get monetized compared to the larger workload of the converting high resolution images. So im2im introduced the negligible overhead, which means it doesn't impact practical usability, even with the realistically sized images. Okay, so next question is, what can we do with im2im? Firstly, im2im can be directly used in textual programming activities. Developer can write code in Python, for example, can freely connect functions from different libraries without worrying about convention details. Secondly, it enables user to reuse functions across the diverse formats. For instance, a visual debugger for neural networks can work with images, no matter it comes from PyTorch or TensorFlow. Most importantly, it can be used to enhance visual programming systems. So visual programming systems are environments where programs are built by connecting these visual nodes. Each node represents operation graphically. As you can see, this is a very simple blockly example. So more practical application used to enhance visual programming systems. So let's consider visual programming that supports build image processing tasks. For example, this task involves denoising, also detection and optical disk annotation. So in the base blockly just the base visual program system, as you see, these functions used are from 3 libraries: OpenCV, Saha image, and Pillow. The steps in the dashed box are the necessary conversions to issue capability in terms of data types, color channel, pixel intensity range across different image formats. So in the blockly-based visual programming systems enhanced by im2im, all the conversion steps are automated, enabling no programmers to focus only on high-level image processing. For example, here, only read image, like denoise, filter, and annotation. So similarly, this is another example involves denoising, super resolution, and contrast enhancement. Again, in the basic blockly-based visual programming systems, we use functions mainly from 2 libraries, Saha image and PyTorch. And the functions in the dashed box are the necessary conversions to issue capabilities in terms of data type, pixel intensities, minibatch style, memory layout. So again, in this using im2im, all conversion steps are automated. So to summarize, im2im automatically converts in memory image representations across multiple libraries using a knowledge graph. So it's guaranteeing the least cost conversions will minimize information loss, and it can be used in practice, especially to enhance visual programming environments. So beyond the images, this approach can be extended to geometry entities, which difference in data types, coordinate systems, units, and other attributes. And also it can be extended to audio formats and other domains. Thank you for your attention. I'm happy to take questions and comments.
Thank you. So we do have time for 1 or 2 questions. So maybe a quick one. I'm not sure I have really understood the experiment you have been conducted. Could you give us some details about the implementation and what you are comparing to what? When you compare with the baseline, at some point you mentioned something, but
yes, you mean
you have been quick on that?
Yeah. So you say our im2im just follow this pipeline, and the baseline is just simulate how people to manually write the conversion steps, and it's only execute this pre-compiled conversion code. We want to see if this graph search and synthesis, these 2 steps, take to see if have larger influence or not.
Okay. Okay. Good.
Thanks.
Thank you. So let's take the speaker again.